And this is just to tell you all that when you standardize the data, let me insert another column. When you standardize the data, the property of that standardized data is average should be equal to 0 and standard deviation should be equal to 1. Let us see whether we will get that or not. Alright. And the formula to standardize is Z is equal to X minus mu divided by sigma. In order to calculate mu, that is mean, you just need to type in average of these data points. And if you want sigma or standard deviation, it is nothing but standard deviation of these. Now if you want to get standardized value of top speed of the vehicle, what is the formula? X minus mu over sigma, this one. So it is X minus mu divided by sigma. I got a value. On similar lines, formula is X minus mu divided by sigma. I repeat, it is X minus mu divided by sigma. Now if you calculate the average of the standardized data, you need to get a 0 and standard deviation of these numbers should be equal to 1. If you all are wondering on, hey, this is not 0, it should have been 0, then hold on to your horses, let me explain this. If a value is very lengthy, Excel is going to condense that using this E. How do you write this? 6.43929 multiplied by 10 raised to the power minus 15, and that is equal to 0.1234567891011121314, and then you get your values. Isn't this roughly equal to 0? Oh yes, this is approximately equal to 0. And this is how your Excel sheet would represent. Not Excel sheet, any of your statistical tools also would represent such a big lengthy number in this fashion. Alright. Now, my bad. Let me calculate, or let me show you the standardized value for weight. So if you want to calculate the mu, it is average of all these values, and if you want to calculate sigma, it is standard deviation of all these values. What is the formula for standardization? Z is equal to X minus mu over sigma. So let me erase this. Formula is simple. Z is equal to X minus mu over sigma. You calculated mu and you calculated sigma there. Let me type this as standardized weight, and the formula is X minus mu over sigma. X minus mu over sigma. X is a random variable, by the way, which takes 3 values. So if you want me to expand this, this is x1 minus mu by sigma, x2 minus mu by sigma, and this would be x3 minus mu upon sigma. Now, the property of standardized data is that average should be equal to 0 and standard deviation should be equal to 1. right? Again, if you're confused on what this value is, this is not 0. If that is what you're assuming, then let me tell you that this can be written as minus 2.60902 multiplied by 10 raised to the power minus 15 because you have minus 15 there. And again, the same logic follows. You need to put in 15 zeros or 14 zeros and 2. So it will be minus 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 2, 6, 0, 9, 0, 2, and this is approximately equal to 0. And why are you standardizing the data? Because when you standardize the data becomes unitless. There is no longer any dependency of units, and hence you can very easily proceed with the prediction models. Yeah, that is the reason why you're making the data unitless. Since you're standardizing the data, the name given to this distribution, if you plot a distribution for this, it would be called as standard normal distribution. This standard normal distribution is also called as Z distribution. These are all probability distributions, right? It's just given a name Z distribution because the formula is x minus mu over sigma. All right. Now, another thing that I wanted to explain you all here is, fine, I'll explain that using a different explanation altogether. All right. So this is the key formula, Z is equal to x minus mu upon sigma. And any random variable that you have, you can convert that into a standard normal distribution, right, by standardizing the data using this formula. Why do we standardize? To make the data unitless. Another reason, as the name itself implies, if you standardize something, it'll be easier for you to analyze. Rather than analyzing for each and every random variable, you can standardize and have a common representation, which you'll learn very soon.